Right, guys. The problem here says solve using Cramer's rule. I already written the Cramer's rule. So understatement. And according to the question, how the question is it says solve for x1. But in this case, for this discussion, we're going to solve for all the unknowns altogether. Just to do it, repeat it so that people can master how we go about the whole thing. Oh, that's right. Because we're not writing an exam, we are just writing, we are discussing just. Now, Cramer's rule, I mean, this might sound very funny. Cramer's rule, for me, is more mechanical than analytic. Maybe the theory which led to Cramer's rule needs some kind of analytic mind and all those things. But when you get to Cramer's rule, it's more like moving bricks around in a very, very mechanical way. The only thing what you must do, you must know what moves to where and whatever. And I think there, your eyes are more important than anything else. You must see exactly what is taken to where. Now, coming to that, Cramer's rule uses determinants. So then, when you use Cramer's rule, I think, let me draw a kind of a line here. You must be able to represent this system in matricial form. In other words, you must see that there's a matrix here, 5, 1, minus 2. Oh, minus 1, yes, minus 1. I'll correct it, that one. 1 and the minus 1. Let's correct the first law. Right, K is minus 1. Then it's 1 minus 1 and 5. And then this is the matrix of the coefficients. So, because if you don't have that kind of view, that is that matrix, I don't know what you're going to do in Cramer's rule. There's nothing you're going to do. So then here, what you're going to have here is x, y, and z. Even if you don't write this system this way when you're using Cramer's rule, but that kind of understanding must be somewhere in the background of your thinking and whatever you want to call it. So then independent terms then becomes 4, 1, and 2. So when we've written the matrix in that form, we say it's in matricial form. It's just like, is this, what is this? This is A, X equals to B. I think even if we're not going to use the inverse, this kind of setup is important. Now, what does Cramer's rule say? First of all, that's also important. You can't use Cramer's rule if the determinant of this matrix is what? Is 0. It actually means that that system has no solutions anyway if the determinant is 0, isn't it? So once you have to use Cramer's rule, it must be clear that the determinant of that matrix is not equal to 0. That is kind of a necessary condition there. So now, what does Cramer's rule say? Cramer's rule just tells us that all these variables, all these unknowns we're looking for are fractions. Did you hear what I said? I said Cramer's rule says all these unknowns we are looking for are actually fractions. In other words, they've got a rational kind of an expression. Then if something is a fraction, there's a denominator, there's a numerator. All together? Yes. Make that point sit down. Sit square in your head. The denominator is common. So these things are rational expressions. The denominator is common. But what is the denominator? The denominator is actually the determinant of that. Is that determinant which is not supposed to be 0? In other words, the determinant of the coefficients. This is how I present this thing. Just check. First thing, Cramer says these unknowns have got a rational expression. Rational expression called denominator and numerator. The denominator is common. So now what is the common denominator? This determinant of the matrix of coefficient, then that is 5, 1, minus 1. And 9, 1, minus 1. 1, minus 1, 5. Same thing here. 5, 1, minus 1. 9, 1, minus 1. 1, minus 1, 5. 5, 1, minus 1. 9, 1, minus 1. 1, minus 1, and 5. So we know these variable, these unknowns are rational expressions, they've got a common denominator. If they've got a common numerator, then there's nothing we're doing. You understand what I'm saying? If they've got a common numerator, then there's nothing. Actually, there's nothing called common numerator. My students are the ones who have taught me something called common numerator. Maybe when we get it, I'll show you when students have got things called the common numerator. Right. I'm going to draw 3 lines here. This is the first day I'm doing this thing. I'm going to draw it exactly like, I don't know. I told you that I want to do it in such a way that you are not going to forget it. I'll say first number 1, variable number 1. I'm looking for x. That line says that column is going to, sorry. It's good that I make a mistake, then you are going to do the same mistake, you will correct it. Okay, so then it says that column, I'm going to replace that. Now I'm going to replace the column of the variable I'm looking for in the equation. And then I'll write the, or let me write it in red, yes. So that people can see 4, 1, 2. The rest, 1, 1, minus 1. Minus 1, minus 1, and 5. The only thing I'm left with now, I must know how to compute determinants. Then let's get to the next one. I'm not doing determinants, I'm just showing people what the mechanics of going around this thing. Then number 2, I'm going to cross this. Then there, let me use red again, so that the red is our column which we imported from somewhere. That's the import. The rest is the same. 5, 9, 1. And then minus 1, minus 1, 5. Right. If you knew how to do this thing, then you didn't need to ask this question. But if you don't know how to calculate determinants, then you should have asked about calculating determinants. Because this thing is nothing else but just calculating determinants and organizing the type of determinants you want. Then, coming here now, let's get the last one. Let's get another color there. Let's go. That's where the import is going to go. Then we go 4, 1, and 2. Then the rest does not change. It's going to be 1, 1, minus 1, 5, 9, 1. We are done. I mean, as far as Cramer's rule, we are done. Then the next question will be, do we know how to calculate determinants? And here there's a choice. Which method, which approach do you want to use to calculate determinants? There are several approaches. There are several approaches to calculate determinants. So how many do you want me to show you? I will show you 3. I will show you 3. Let's start with the determinant of the coefficients. All together. Let me do this. So what are you saying, my sister? Yeah? You're saying yarn, eh? Right. Now we want this determinant. Let's call this matrix A. We want determinant of A. Let me, I don't know, maybe let me, I don't know which one to start with, but I will just start anyway. Let me just start anyway. Let me start with this one. I call this one diagonals and the parallels. The name is not important, isn't it? It's just my kind of way of easily communicating with you. Diagonals and the parallels. So I take that diagonal. I take the parallel. The diagonal has got 3 entries. The parallel I've got there has got 2. Then I go around and borrow 1 from this side. Did you hear what I said? I said diagonals and the parallels. I take the diagonal, I've got 3 entries. Then I get this parallel, I've got 2. I need 3 like the, then I go and borrow the 1 which is that side. Then I come to this parallel. Parallel, I've got 1. I need 3. Then I go around and borrow those 2. And all these I add. I add what? The product of the entries. So what am I going to write now? Check what I'm going to write. I'm going to write equals 5 by 1 by 5 plus 1 by minus 1 by 1 plus minus 1. Never leave this thing as clumsy as this. By by 9 minus, then I can put a big bracket here just to avoid that. Now I'm taking the other diagonal now and its parallels. All together. I come to this one, I've got 2. I go and borrow 1 that side. I come to this one, go to 1. I come and borrow that side. I can even draw a circle like this. You see that? I can draw this circle like this. So what do? I multiply things which are on my circle. This one, if you want to make it circle, it's up to you. All together? Yes. Then what do I do now? I go take the products. It's a 1 by 1 by minus 1. All together? Plus, again, I add these ones, isn't it? But what I do, I find the difference between these 2 sums. So I find, check this, I'll write it here. Find the difference between these 2. It's actually this one minus that one. Isn't it? This one minus that one. So this is the one, the red one. This one is the green one. So what do I have now? I've finished with that one. Then I come to 9. 9, 1, 5. 9 by 5 by 1. I just went this way. 9, 1, 5. Which was 9, 1, and 5. But its multiplication does not worry about the order, is it? Then plus 5, or this 5 now, ne? 5 minus 1 minus 1. So minus 1 minus 1. I'll cheat there and write 5 there, multiplying that. Because I don't have space to write that side. Yeah. So now, what do I have now there? I come and do this now. Let's do all the calculations here. So it's 25, and this is what? 9. So it's 25 plus 9. What do we get? 34. Am I right?
Yes.
Minus 1. That's 35. No. 33, sorry. 33. Minus. This minus. What do I get here? 45. Is that right?
Yes.
45. This is plus 1. 46. Minus 1.
45.
45. So 45 here. Is it a minus or positive?
It's minus.
A minus 45 or a positive 45? I mean within the brackets, positive 45. Then there's a minus there. Then you've got a 45. Then,
45.
okay, I know that pen is not behaving properly there.
49. It's 49. Is it 49?
49 or 45?
What's 45 there?
Oh yeah, this 5, yes. So the pen was right. We were all wrong, but the pen was right. So it's 45 here, plus this 5, 50, minus this one, 49. So the pen was right. The pen was right. So it was wrong. Then, what is the answer?
Minus 60.
Minus 60.
16.
Okay, minus 1, 6. And this is not equal to 0. So those divisions there, they are valid. All together? Okay. So we've got that. So now let's temporarily focus on the determinant to get the ways of calculating determinant. Is it? Yeah. We're doing a crash course on determinant before we get to Cramer. Let's get another one. So I'll use exactly the same matrix so that you can confirm that what we did is correct.
Before you go on,
Yeah.
is there a way whereby we start to put the parallel one and it subtracts the diagonal one?
I don't quite understand what you're saying.
There, it is the diagonal minus the parallel. No, it is the one in red.
Yeah.
The diagonal.
Yeah.
Then the ones in
Green.
are the parallel. So the diagonal.
No. The diagonal is this one.
Yes.
Its parallel is this one, and this parallel is that one.
So,
it's so that I compensate these other parallels which are not 3.
So I'm saying that diagonal in its members.
Yeah.
Is it proper if I start with the other diagonal side? Yeah, the next one.
Yeah, and subtract the other one.
This one.
No. Remember, subtraction has got it respects the order. It's not the same thing. 5 minus 6 and 6 minus 5. So subtraction is strict with the order there. Okay, right. Can we say this one is fine?
Yes.
It's okay. What I'm going to do now, let me just. So I've cleaned up. We can start afresh with another method. Is that all right?
Yes.
So we start again by determinant of A. Let me tell you something. This is the technology which works for me. Yeah. This technology, I'm not the slave of technology. This technology is my slave. Yeah. So we do this way. Let's write 5, 9, 1. 1, 1, minus 1. Minus 1, minus 1, and then 5. Then let's do something here. That's just a line. We basically like calculating a determinant of an argumented matrix. What are you going to argument here? You're going to go 5, 9, 1. 1, 1, minus 1. And that. If you look at that thing, we've got all the products which we had before on the parallels. And we don't need to turn any line. We just go. Am I right?
Yes.
This is not a trick, it's just organizing your work in a certain way. We'll add this. We'll add these products. We'll subtract the red products, the sum of the red products from, we subtract the green, the sum of the green products from the red. Are we together? So let's go. By let's go, I'll just mean let's do it. 5, 1, 5 plus 1. Oh, sorry, I looked at 15 now. Okay, because I didn't put the dot there. Okay, minus 1 and 1. Are we together? Then the last one, plus minus 1, 9 minus 1. Minus 1, 1 and 1. Plus 5 minus 1 minus 1. Plus 1, 9.5. If not, those products are not the same one we got before, then I'm wrong. Are we wrong or right?
Yeah, right.
I mean, we can't expect anything here. We should expect what? The same number. What is the number? Minus 16. Minus 16, is it? Because you see that the products are the same, we can conclude that one. That one is easy. Maybe we've got to stop there because we are just, this is about time up. But do you mind? Do you mind that we continue a bit?
Yes.
We don't mind. Now, if we go back to our z, to our x, we now just say x equals 2 over 16. You get our y, or negative 16, over negative 16. And our z over minus negative 16. Then we put our numerator. It was 4, what? 4, can you check in? 4, 1, 2. Then the rest, 1, 5, 9, 1, 1, 1, minus 1. Everybody knows how to calculate that determinant, is it?
Yes.
Then, coming here is 5, 9, 1, minus 1, sorry, minus 1, 5, because remember I want to indicate our import in a different color. Okay, then we come here, 4, 1, 2. 1, 1, minus 1, minus 1, minus 1, 5, then Then we calculate the determinant. All together. Yeah. So then this is what Cramer's rule is. I don't know who had the problem with this. Was it calculating determinants or it was playing around with the Cramer's arrangement? Yeah, but now you see it. Ne? So now, okay, what I can say now, I think because of time, we are left with one approach to calculating determinant. But if you really want it, I will see it next time. I will show you that one. But if you are not in a hurry, I can show it very quickly. You're not in a hurry. Or maybe let me present it to them. Then you will see it on the continuation. You want your paper?
Yeah.
Okay.
Are you going to use it? If you're going to use it, you can leave it.
No, not read. Not read. It's 5. It's 5. Okay. Yeah, let's just finish this one. Now, let's take our matrix A. That one which starts with a 5. 5. Give me the numbers. 5, 9, 1. 1, 1, negative 1. Negative 1, negative 1, 5. We want the determinant of A. Now, no, want to calculate another approach. You want to use another approach. Yeah.
Okay.
Want to use another approach. But I want to use this one so that when we get to the right answer, we can confirm that it's really working. That's right. Right. Now, here we are going to need something called the minus. This is a new kind of entity called the minus. These are objects which are called minus. And we're going to need also something called the core factors. All together? Okay. What is a minor? A minor, I will translate it, I will take it in a common. When you say that somebody did this to a minor, you are referring to somebody teaching to a small guy, small child. So a minor here is like we deal with the determinant of a smaller matrix. Now, I'm just trying, with that kind of argument I'm saying now, talking about minor, what, I'm just trying to strike some similarity, because striking similarity is very, very important in learning. If you can strike similarity of something new with what you know, you will never forget that. What is the minor? Well, let's quote here a one minor. I'm going to call it A11. This is actually a determinant. Then I'm going to write it as a determinant. The question is of what? This is what I'm going to do. I'll drop row 1. I'll drop column 1. Did you see that? Yes. So my minor will be a determinant of 1 minus, sorry, I don't want to write in black, in red. I prefer writing in black always. Then minus 1 and 5. That's the determinant. Then you can quickly calculate that determinant. What is that determinant? It's 5 minus 1. It's 4. Then I'll get another minor. I'll get another minor which I'm going to call 1, 1, 2. In that case, what am I doing? I'm moving this to there. Then get my pen and that. Listen, I normally tell my students that some things you don't need to understand. You need to see them, yes, how they happen. This is one thing where you need to see what's happening. The mechanics. Yeah, the mechanics of it, yeah. So now what have you there? 9 minus 1, 1, and 5. Then you get 45 plus 1, 46. Then I come to A1, 3. You see what I'm doing there? I'm moving along a row. All together? You could also calculate the minus moving along a column. Any column, any row. Then you go so what do you do then? 9 1 1 minus that. 9 minus that minus 10. Listen to me. There will be a time when we need something. We are going to calculate all the minus for all the positions. Remember, this is 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. For other things, we might need to calculate all the minus, especially when we are calculating the inverse. I don't know whether I've done that. Have you done the inverse?
Yes.
Using this method?
Yes.
Yeah, so we calculate all the minus. But now we don't need all the minus. Then what do you do now? Once you calculate the determinant of this, then you need a cofactor. Cofactor, for now, let's not really argue about why this and that, but the formula suggests that the cofactor for this is now going to be, let me say, cofactor kind of thing. Minus and cofactor. If I write now this thing with the cofactor, I'll have this minus 1, 1 plus 1 multiplied by 4. So now I've got a cofactor. Look at what's happening there. I want the cofactor from this. I multiply by minus 1 to the power 1 plus 1. 1 plus 1 is the position of that. Row 1, row column. Then I get that. They are going to do the same thing.
Weren't you supposed to multiply it with the number of missing positions?
No. This is just a cofactor. I'm talking about the cofactor. Yeah. You are already calculating the determinant.
Yeah.
I'm talking about the cofactor. Then here, the cofactor, I'll get it as minus 1, 1 plus 2 multiplied by 46. Okay, what you see here, these numbers are not going to change. They're only going to change the sign, plus or minus.
Yes.
Yeah. Then 1, 3. This will be minus 1, 1 plus 3 multiplied by minus 10. So once you've got those cofactors now, what do? This will be plus 4, isn't it?
Yes.
Then you come here and say, we're calculating determinant now. Let's do this. We're calculating determinant now. You go to position 1, 1. When you get to position 1, 1, there's a 5 there. You take that 5, multiply it by 4, because this is 4, isn't it?
Yes.
Plus, you go to position 1, 2, there's a 1 there. You take that 1, you multiply it by the cofactor. This is a 3. 3 negative signs make negative. So you multiply by minus 46. We go to the next thing. You take the position there. It's minus 1. Look at how I'm writing my signs there. Carefully, you have to do that. Otherwise, you write junk. Then you take this one. Is 4 negative signs. They make positive. So minus 10 remains minus 10. Minus 10. Then the rest of things now is simplified. What is this? 20, no? What is this? Minus 46. What is this? Plus 10. What is this? Minus 16. So if you are doubting Thomas, you believe by seeing, then it will see. It's working.
Yeah, it's working.
All together?
Yeah.
Okay. So guys, these are the 3 approaches which I have for calculating determinants. I'm not going to advertise any one of the 3. It should be up to the choice of the consumer. You choose what you want and what you like. Then you go on with doing your mathematics. I hope you enjoyed it. If you didn't enjoy it, it wasn't my intention. Thank you for listening.
Thanks.